So we're going to start off with Michael Grose. He's a research scientist at CSIRO in Australia. He's also a member of our Strategic Ensemble Design Task Team. And today he's presenting a multi-model downscaling ensemble based on CMIP6 data. So take it away, Michael, please.
Thanks very much, Eleanor. And I'm just attempt to share screen now. Hopefully that's appearing, and then I'll go to full screen and see how we go. How does that look?
That's good.
Great. Thanks so much. So I'm presenting on behalf of many partners and collaborating organisations in Australia, and a lot of their logos are shown here. So this is from where I work at CSIRO, but also the Bureau of Meteorology, universities, state partners, and more. And I'm going to be talking about the strategy that we're employing for producing new climate projections for Australia to use in climate change services, which has always used CMIP for the last kind of 20, 30 years, and we'll be using CMIP6 and looking forward to CMIP7 as part of our climate services. So in Australia, we've seen many record-breaking climate events in the past decade, including fires, floods. You might have heard of the Black Summer fires in 2019 summer, the recent floods in 2022. So Australia has faced many challenges from climate variability and also now emerging from climate change as well, including many different types of extremes. So this was part of the motivation for a Royal Commission in Australia into natural disaster arrangements, and also fed into the ideas behind a national projections roadmap. And both of those things asked for Australian projections to have a very strong focus on extreme events and understanding them and understanding how they're changing and how they could change in the future. And so when we started to look at what to do in terms of climate modelling to underpin climate services, we thought about what's the best balance here. There's CMIP, there's statistical calibration, CORDEX, there's perturbed physics ensembles, convection permitting modelling, and more. And what's the best combination to use to get breadth in terms of assessing different models, large ensembles, different physics, but then also have depth in terms of high resolution and complexity. And we are aware that there's different strategies used around the world, and there's just a few examples there shown. So Canada has an atlas based on CMIP5 with statistical downscaling, UKCP 18, among other things, used perturbed physics ensembles, and we looked at the NCA5, used CMIP6 with statistical calibration. There's a lot of different options and possibilities. So through an exercise and a kind of discussion amongst the research community and user community, we came up with a strategy which put a strong emphasis on a multi-model, multi-scenario ensemble following CORDEX guidelines, and to use that in effect much more than in previous generations of projections. But along with that, to also draw on CMIP6 itself and large ensembles from CMIP6 as well for that breadth, and also use opportunistically use of convection permitting modelling for added insights and depth, and also to explore the use of emerging technologies such as machine learning. And here's a few photos from one of the meetings that we held to start thinking about and strategizing around new climate projections for climate services. So what does higher resolution through things like CORDEX give us? Well, it gives us important regional insights, including important effects for Australia, such as the effect of topography, such as the eastern ranges of the Alps in mainland Australia and for Tasmania. More insights about things to do with land-ocean contrast and so on, all those benefits of regional climate modelling and dynamical downscaling. It also allows you to have a look more at the sub-daily timescale and explore things to do with extreme events and extreme weather. But we're also very aware that there's issues to manage when you use dynamical downscaling. Regional climate models give different results, so therefore a multi-scenario, multi-model ensemble in a GCM matrix is considered good practice, and that's what we're following. And there's also the so-called garbage in, garbage out problem. So RCMs can't overcome biases in GCM. So we need to account for GCM bias and what we're inheriting and evaluate the RCMs for the role they play in the uncertainty cascade. And this is a little animation showing what we get from one of the regional climate models that are being used, the BARPA-R model, compared to the host model that uses input. And you can see, obviously, the added realism and added detail. So what's the advantages in following CORDEX guidelines? So we see that there's an advantage in following these international standards that our results are intercomparable, we can benchmark against other regions, and we can connect to the global community. It also allows coastal applications, because we've got a pretty good area of ocean around Australia that will be modelled as well. So we can do things like wave modelling. And it's also that there will then be a resource for the region, so including for Australia, but also New Zealand, Southwest Pacific and Southeast Asia may want to draw upon these data as well. So we'll acknowledge the full range of plausible pathways. We'll have a special focus on two, the SSP 126, roughly Paris compliance scenario, and SSP 37, a high pathway, which is kind of a fallback from SSP 585, which is extremely high. And this was the CORDEX guidelines, and we're kind of finding that our users and stakeholders are kind of seeing the logic behind these two to kind of bracket a range of plausible change while acknowledging the full set of possibilities. We'll also have a strong focus on global warming levels. So what does Australia look like at 1.5, 2 and 3 degree worlds compared to what it looks like today and relative to that pre-industrial climate? And also provide people with simple rules of thumb for when and how we get to those global warming levels so that they can kind of interpret those. And this is just a plot of the assessed warming levels when we'll get there according to the latest IPCC assessment. So to do this, we needed to form many partnerships. We've got 4 main groups contributing to the CORDEX Australasia ensemble: Queensland Future Climate, the NARCLIM 2.0 program, the BARPA model through the Australian Climate Service, and CCAM through the Australian Climate Service. And each of these have got careful sampling of CMIP6 models and feature also some further modelling down to convection permitting scales for subregions within Australia. And these are arranged into a kind of a GCM RCM matrix. And this was enabled partly through a new body we formed, the National Partnership for Climate Projections, to enable that partnership and cooperation. So I guess this is the core part of the paper that I'm kind of presenting here, which is how we selected models. So we assessed up to 50 CMIP6 models. First and foremost, we had a big restriction on what we could choose. So the daily data available for the 2 core SSPs were reduced down to 35 out of 50. And then for sub-daily data required for all levels, required for some regional climate models, we're down to 18. So that was a big restriction. Then we also performed evaluation, and we rejected models consistently in the lower end of evaluation or failed a meaningful threshold that we could see as being a meaningful level on which to kind of cut off. So we, of the 50, 19 of those were rejected, 7 had kind of at least one flag, and 7 out of the 18 of the subset were also rejected, which kind of reduced our selection even more. We also assessed independence and chose models from different families, and we used a threshold from the literature there from a Brunner paper. And then we looked at the representativeness in the signal. So we wanted to cover the CMIP6 spread in temperature and rainfall change for broad regions of Australia, and also represent the spread in key circulation features. And for us, that's the subtropical ridge and monsoon shear line. And we would have, would obviously like to look at others as well, but those 2 we could get to. And this is just an example of the spread of all models and the ones we chose and how it kind of spans the spread of all models. And also just noting that those particularly hot models we're kind of treating in a special category. So in terms of the hot models, as we all know, CMIP6 overrepresents the hot end of climate sensitivity and warming. And this, the subset of 18 which had available to us, the problem is still there. And many of our mid-range models that we would have liked to choose for the representation of mid-level warming were rejected or weren't independent. So we found that a balanced sampling of climate sensitivity is just simply not possible amongst such a small subset of models. So what we chose to do was have one representative very hot model, representative of that low likelihood high warming, and the lowest end we could get, and then also use all the ones in the middle that we could. But also noting that using global warming levels standardizes climate sensitivity, so that kind of helps a little bit there. Plus, we decided to take a focus on representative futures rather than usual traditional statistics. So what does that mean? That means like, well, we're sampling CMIP6 and sensitivity and so on is restricted, and our RCM ensemble is as big as we can manage, but it's still very limited. It's far smaller than things like EuroCordex. So therefore, traditional ensemble statistics like mean and spread can be a little bit dubious in that context. And we don't want to suggest that we're being probabilistic anyway. So therefore, we're kind of taking a little bit of focus off the ensemble statistics and instead cover key representative climate futures concept, which is a bit similar to kind of storylines, where we have a deep dive on key different types of futures that are meaningful on the ground, such as a much drier future, which is best represented by the Access ESM model, wetter and much more variable climate for much of South and Eastern Australia, which is kind of an unusual projection, but can't be ruled out, best represented by the EC Earth models, and so on. And what we end up with is a kind of a sparse matrix of GCMs and RCMs with those key features downscaled by all of the models, but then gaps also remain in other ones, but that's okay because sampling more GCMs is more useful than filling the entire matrix up. But having that deep dive on some key features like the dry feature in our Access ESM model, using 2 limited area models, stretch grid model with and without bias correction, and using a coupled regional climate model means that we can really test that future in terms of what downscaling does to it and what difference that makes. So once we've got this resource and it's virtually finished, so we're just about to go into production on the projection side, we can use this plus CMIP6, large ensembles, etc., to look at things like signal to noise, get that greater breadth from those other sources, and provide context for downscale simulations. But we're also really grappling with this right now, and there's no one set method or textbook of how to combine these different information sources. So we're going to have a careful think about how to bring all this together, and bring it together with other lines of evidence, including past trends, process understanding, etc. And then we're also having a careful look at what is likely missing from CMIP6-based ensemble, including so-called missing narratives, different kind of features in terms of forcing, such as overshoot or big volcanic eruptions, and in terms of the response. So tipping points and what they mean for Australia, warming patterns that might be missing from CMIP6 and so on. And even though we're just kind of getting to the point where we're getting to the production end and finishing, we already know what we can do better next time. And this includes streamline the model metrics, the climate sensitivity, independence, evaluation and assessment of representativeness. That would really help to move things along faster. Move from evaluation to objective benchmarking. And then also, hopefully more sub-daily data from more models will be available next time. And ideally with the ability to accept, to select ensemble members that are the most appropriate to be representative. And then a big new thing we're very aware of is using regional climate models in combination with emulators and machine learning to optimize that breadth and depth balance would be a great way of the future, we think. And also have some more depth on scenarios that are now of high interest and relevance, such as overshoot scenarios. So hopefully that's given you a bit of a taste of our process for developing the modelling to underpin climate services for this generation of climate projections in Australia. And I look forward to answering some questions. So thank you very much.
Thank you very much, Michael. That was great. Has anyone got any questions? Please put your hand up or you can write them in the chat. So Tim, I think you've got one.
Hello, yeah. Thanks, Michael, for this great presentation. And I was just wondering, yeah, because as far as I know, Australia is affected by a lot of interannual modes like ENSO and IOD. So I just wonder how it would fit into this kind of study as far as I'm concerned. Yeah, that wasn't mentioned in your talk, but just want to have some of your thoughts on that.
Yeah, I didn't go into detail about the evaluation of models for selection for downscaling, but we did include aspects about the El Nino Southern Oscillation and the Indian Ocean Dipole and the Southern Annular Mode, some of these really relevant drivers that then affect Australia, and the teleconnection to Australian rainfall as well. So that was included in the assessment and evaluation of models. Yeah, very important for Australia, yeah.
Oh, thank you. Yeah, great to hear.
Helene?
Sorry, when I cannot unmute myself. Yes, a few questions. This wasn't the question I was going to ask, but to follow on from that, with the evaluation, I think we've heard this with Euro CORDEX as well, like, and in fact with the CORDEX steering committee, you know, this real need to evaluate the models on the regional basis before one can, you know, use them for that area. And so I guess this is just your thoughts, really. You know, one thing we have the ambition for in CMIP is to move much quicker from the CMIP global simulations to, you know, the downscaling and the CORDEX, the regional simulations. And it's just like, how can we speed that up? Is it once it's done for every region, it can provide a recipe for Australia, for example, next time, and it would just run through it in an operational sense?
Yeah, I think it's a really important point at how we can all plan to do better in CMIP 7 generation. And I can see that we looked at some pretty broad scale evaluations about the whole Indo-Pacific region to see if there's some kind of real deal breakers in some of the models for our region, and then also some more locally relevant ones as well. So it seems to me that evaluation in a kind of a tiered way. So if there's global evaluation that's relevant to everyone, and then regional evaluation as well for people to draw on. And yeah, it does seem that models that kind of pass a sanity check for the globe, but are rejected for some regions and accepted for some other regions, is reasonable, as long as it kind of is pretty comprehensive for that region. But yeah, I think a tiered approach seems to make sense.
Yeah. Yeah, okay, thank you. I mean, yeah, it's just like, there's so many regions, isn't it, is getting this right. But, absolutely. And this is, a really, good kind of benchmark for other regions as well.
I mean, I think I've heard that CMIP is, CORDEX is going to set up a task force about preparing for CMIP 7. So it'd be good to have all of these discussions within that kind of cross CMIP CORDEX grouping. So we can be really prepared for that kind of next set coming through. Hopefully that can then move a bit quicker through the kind of downscaling process.